Physics, and in this video we'll be covering the practice problems on page 133, numbers 33 through 37. In number 33, an ant climbs at a steady speed up the side of its anthill, which is inclined 30 degrees from the vertical. Sketch a free body diagram for the ant. So here we see the ant on that incline and is 30 degrees from the vertical. Now, whether that's typical or untypical, a lot of times we usually see that 30 degrees from the horizontal. So please pay attention to where that angle is referencing. We see the two forces acting on this ant. The normal force from the side of the anthill and its weight. Now quite often what we want to do is split that weight up into its two components, what I refer to as mg perpendicular and mg parallel. That is the component that's perpendicular to the incline and the component that's parallel to the incline. Alright, number 34. Scott and Becca are moving a folding table out of the sunlight. A cup of lemonade with a mass of 0.44 kilograms is on the table. Scott lifts his end of the table before Becca does, and as a result, the table makes an angle of 15 degrees with the horizontal. Find the components of the cup's weight that are parallel and perpendicular to the plane of the table. Okay, so here we see the cup on that 15-degree incline. We see the weight of the cup is straight down. But we want to break that up into two components. One that again is perpendicular to the incline and one that's parallel. We're trying to find out what those two components are. So mg perpendicular is equal to mg cosine of 15. The reason that I've chosen cosine this time is because mg perpendicular is adjacent to that angle. That 15-degree angle is at the top of our blue triangle. Plugging in what the mass is, what g is, we find out that mg perpendicular is 4.2 newtons. Now mg parallel is mg sine of 15 because mg parallel, oh, excuse me, that's supposed to say parallel, not perpendicular again, but whatever. Mg parallel is away from that 15-degree angle. So following it along, plugging in, we see that it's 1.1 newtons. Now from the triangle, and I actually did measure these angles out as I drew them, we can see that that perpendicular component should be quite a bit bigger, and my math supports that. Now, number 35, Kohana, who has a mass of 50 kilograms, is at the dentist's office having her teeth cleaned as shown in figure 514. If the component of her weight perpendicular to the plane of the seat is 449 newtons, at what angle is the chair tilted? So here we see that picture of Kohana. I've drawn in her weight, mg. I've split it up into the components mg perpendicular, which we know is 449 newtons, and mg parallel. We're trying to figure out what is the angle of the chair, so we're going to take that mg perpendicular and set it equal to the cosine, and set it equal to mg cosine theta, because again, the angle of incline is matched at the top of this blue triangle. So we see that cosine theta is equal to mg perpendicular divided by mg. Now that's just simple division. I'm going to plug in my numbers for mg perpendicular, which we're told is 449, and I'm going to plug in and find her weight just by taking mass times gravity, and her weight is 490 newtons. Now this inverse cosine that we see on the screen is how we get rid of a cosine in trigonometry. Okay, it's an opposite operation, and much like cosine, sine, tangent for you guys, it's really just a button on your calculator. It's just a button you need to learn how to use. It's usually second and then your cosine button. And we see that the angle is 23.6 degrees. So that's 23.6 degrees relative to the horizontal. Okay. Taking a look at number 36, Fernando, who has a mass of 43 kilograms, slides down the banister at his grandparents' house. If the banister makes an angle of 35 degrees with the horizontal, what is the normal force between Fernando and the banister? Now, I didn't have a great picture to go along with this, so I'm going to model Fernando as a rectangle. Doesn't matter what shape he is, I just can't draw well. Get over it. Splitting his mg up into its two components again, we want to do a sum of forces in the y direction. Now the reason to do that is just to show that the normal force is equal to mg perpendicular. So that means to find his normal force, I'll go mg cosine 35 degrees. Again, it's cosine 35 degrees because that 35-degree angle is at the top of my blue triangle and mg perpendicular is adjacent to that angle. So it turns out that his normal force is equal to 345 newtons. Okay, number 37. A suitcase is on an inclined plane. At what angle relative to the vertical will the component of the suitcase's weight parallel to the plane be equal to half of the perpendicular component of its weight? So here's a picture, and I've marked theta so that it's relative to the vertical. I've drawn in its weight, mg, and I've broken it up into its two components, the perpendicular component and the parallel component. Now we're told that we want the parallel component to be equal to half of the perpendicular component. Now in this triangle, because theta is relative to the vertical, this angle theta is at the bottom of my blue triangle, not the top. Because we're going relative to the vertical, my angle is at the bottom of the blue triangle. So things kind of switch. mg parallel is now mg cosine theta, and mg perpendicular is mg sine theta. Don't ever get it in your head that one has to be cosine, one has to be sine. Create it as you need it based on where that angle theta is. So I'm going to shuffle some things around. I'm going to cancel my m's, cancel my g's, and I see that I get sine theta over cosine theta equals 2. Now the reason I decided to put sine on top, cosine on bottom, is because sine divided by cosine is tangent. So sine theta divided by cosine theta equals 2 is the same thing as tangent theta equals 2. You just need to know that relationship that sine divided by cosine is tangent. To get rid of my tangent, that is to solve for my theta, I use an inverse tangent. Again, this is just a button on our calculator, typically second and then the tangent button. So theta is equal to the tangent inverse of 2. Plugging that into my calculator, I get 63.4 degrees. All right, it's time for you to try some on your own. I'll see you in class, and I'll see you online.